Hi guys, it's Oladimiji Baye from becomeadatapro.com. Thanks again for tuning in to this video. And in this video, I want to talk about redundant data. Okay, it's a simple but sometimes tricky topic when it comes to handling, databases. So let's get into it. And I'm going to use an extreme example here, okay, just to show an example of redundant data and what I mean by redundant data. And according to Wikipedia, redundant data is data that is unnecessarily repeated within a database but does not provide additional value. And with this example that I'm going to show you, and like I said, it's a bit extreme, but it's just something you need to look out for, okay? And I actually personally think that redundant data in databases, it's a result of poor database design and especially most importantly, lack of database normalization. Okay, because when your database is normalized, which I actually will show you the process I go to take this database and actually normalize it so that we remove the redundancy. But first of all, I want to make an extreme example of redundant data, which is this column here. As you can see, it's extreme, but it's just something to be aware of. Okay. And you can see that this column here it's a simple database, and you've got the transaction ID, customer ID, it's here on all these columns as well. But when you look at this column here, this type of redundancy is called column level redundancy, right? Where there's just too many. We're just even if I filter for it, it's just a single value repeated multiple times in this database, and it's obviously for multiple customers, which, like I said, is an extreme example, but in a real life case you probably won't have customers with the same address, but it's just to show the example of data redundancy. And the reason why this is a bit difficult and might give you a headache if you're working with a real life database is because imagine having to update this information, and you would have to update it in multiple places because you can see these occurs in multiple rows. Okay, and like I said, due to poor or lack of database normalization, we have this issue of data redundancy. But from here, what I did to normalize this data to effectively remove the redundant data is by just separating the, because when you look at the columns, we've got it's supposed to be transaction data, right? So we've got transaction ID that tells us, okay, there's some transactions going on with the transaction amount and date, and we've got the account number and the customer names. So we could effectively separate these into 3 to 4 tables, okay? And when we do that, we're able to, you know, first of all, we split the data into separate tables, and we're able to effectively use foreign keys and primary keys to, how do I say it? To effectively normalize the data and also enforce, that's what I was looking for, enforce referential integrity to make sure that the data is consistent. And most importantly, if we need to update data, instead of us having to update it in so many places, we can just update the data in one table. Okay, and that will save us a lot of headache. So now, like I said, let me show you the steps I took to normalize the data in order to effectively uh, reduce the redundancy. So here's a breakaway table, for example, that I took from the database. I created a separate customer table with the customer ID. That's the primary key, obviously, customer name, and there's an address ID here. Okay, which has obviously the same ID because again, we are assuming the customers all live in the same address. Like I said, extreme example, but go with me here. But here you can see we're using just one piece of information for the address ID that links, this is the primary key, obviously, that links with the customer ID in the customer table. And then again, I went on to the accounts table. I created the accounts, a separate accounts table with the accounts number being the primary key and the customer ID being the foreign key in this table, which means what? The accounts and the customers are linked, meaning customer 1001, this is their account number, okay? And if you want to know, for example, again, which customer has this account number 901, you can just go into the customer table and say it's this customer, it's John Doe, right? So they are linking properly. Okay, there's a relationship between those two tables. Then again, I went into to create a separate address table simply because of the extreme example of that address, right? Of, saying, five customers live in the same address. And like I said, it's extreme, but go with me here. But with the address table, I've been able to create a primary key for the address table, which is the address ID. And obviously, the IDs are separate addresses, but the main address that we're using in the database, this one, right? Now, for example, if we were to update the address information, instead of us having to go through the stress of updating it in so many places in this database, since we have a separate address table, we can just update it in one place here, and it will effectively affect everywhere else, right? Because we've normalized it now. We're going to update. If anything changes, for example, let's say uh, this becomes maybe, I don't know, let's say Door Street or something. Door Street, for example. And once we've changed it in this one table, it will affect every other places that the information is occurring, okay? Which saves us a lot of headache, okay? Instead of having to update it in multiple places, okay? That's the power of database normalization. And then lastly, the transaction table, okay? I've separated the transaction ID and obviously linked it with the customer ID so that you can know which customers are, the transaction ID, obviously different transaction ID belong to which customers, okay? And the customer amount, transaction amount and transaction data as well. But yeah, these four tables that I've now created off of just the simple database is now effectively a normalized database that we can use to make sure that we avoid data redundancy, most importantly. Okay, and then from here you can take these four tables instead of this one that will give you a headache if you're working with, for example, a larger database. This is just 50 rows. And like I said, I used it to make an example. But imagine working with a million rows of data, okay? It's just going to give you unnecessary headache with this redundant data that is, effectively just repeated information that is, not very useful. But because now we've separated everything into the appropriate tables while linking them together and enforcing refreshing integrity with primary keys and foreign keys, you can take the tables like I've just done to somewhere like MySQL, right? Or SQL Server, whichever uh, relational database management tool you'll use, and you can effectively analyze your data without having any issues at all. Okay, and as you can see, I was able to extract the data from the tables by performing, the joins in the tables. And as you can see, this is the result: the customer ID, the customer name, account number, transaction ID, amount, date, and customer address. Okay, that's the key. That's the reason why it's important to, normalize your data. If you're given a data from scratch, maybe you're doing boot camp or something like that, and you're given a because you when you're doing a boot camp, when I was doing a boot camp when I got started in data, they just gave us a generic database like this, just like this, and asked us to create a ER customer what's the EI diagram? I forgot what it's called. Entity relationship diagram. Yes, EI diagram from the databases. When you putting it together, what goes into which, what table should you create and stuff like that. That's the type of challenge you can face when you're creating your databases from scratch, for example. And I know data analysts don't normally create the database from scratch, but these key concepts, database normalization, refresher integrity, those are the key concepts you also want to learn and understand whilst, working with databases, especially larger databases. Okay. And when you're doing that in a professional setting, you're going to come up with data redundancy and even duplicated data, which, I'll probably make a video about that at a later time. But yeah, that's really it on data redundancy. And yeah, it's very important. And once your database is normalized, you can have the peace of mind that if there's ever a time when you need to update the information or something, you can only just go to one table where the information is and just update it. And as long as you're properly referencing the ID, everything will update in every single table. And then you have the peace of mind knowing that your job is done and done properly. So guys, that is it on data redundancy. Okay. And also guys, my last video that I released on my channel is about it's about extracting data from PDF using Power Query, okay, in Excel. So if you want to know how to extract data, make sure you watch my last video. I'm going to leave a link right here on the screen for you to watch it. Like I said, it's Oladimeji Ipaye from becomeadatapro.com. Thank you so much for watching, and I'll see you next time. Take care. Bye.